Okay, so we've got three curves. Y equals x squared. Not too complicated, so that's nice. Y equals 0, which means the x-axis. And then x equals 4, which means this vertical line over here. The region bounded by those three curves is this region right here. So they want the region revolved around the x-axis. So that means it's coming out down, it's revolving from top to bottom, making that weird type of, it's not like a cone because it curves differently. It's like a funnel maybe, when it's being revolved around the x-axis. So what you want to do is find out how you can describe the volume of an infinitely thin right cylinder that's taken everywhere here. So the lines I'm drawing are little, really thin right cylinders, like pennies, even smaller than pennies, you know. So the volume of a right cylinder is pi r squared, except it's pi r squared times h, and our h in this case, we're going to write dx because the height is getting infinitely small. So the volume is pi, and then the r depends on where you are in the x-axis. So the r depends on x squared. The distance from the x-axis to the height of this curve, that's the y distance, right? And to calculate your y distance, it's x squared. So x squared is our radius, and then the volume of a right cylinder is the radius squared. And then h is dx in this case because we're taking infinitely small right cylinders. And so that's the calculus part. We've got something defined for volume of an infinitely small slice, and then we'll make that have actual volume by integrating from 0 to 4 because it starts on 0 in the x-axis and goes to 4 on the y-axis. Okay, so I'll leave that there because that's a pretty straightforward integral. The line y equals -2. Y equals -2 is 1, 2. It's up here. Oh, sorry, that's y equals +2. Y equals -2 is down here. So we've got this region, and we're revolving it around this line. That means we're probably going to want to use the washer method. Okay. Or we could avoid the washer method. I'll show you how in just a second. But so you've got this region. There's a big gap, but we're revolving this region and its gap all the way around. So what we would be seeing on the other side as we revolve it would be something like this. So it's like it's like that funnel shape again, except with a big rectangle, like not a rectangle, but a big right cylinder cut out of the center of it. So we're revolving around the line y equals -2. Let's see. So what we could do is we could find the volume of this region, the big region, and then we could subtract out the volume of that right cylinder that we just talked about down here. Subtract out the volume of the right cylinder right here. And what we'd be left with is the black region that we're talking about. Okay, so to do that, we're taking infinitely small slices again, right cylinders, except this time the right cylinders are bigger. It's pi, and then it's 2 plus x squared. I'll show you why it's 2 in just a second. That's being squared, and then we integrate that from 0 to 4 again. Because we start at 0 in the x-axis, end at 4 in the y-axis. Now the reason for that is because this distance now between the point of revolution is now at least 2 units, right? This is 2 units on the y-axis to get from here to here. So the radius has a minimum of 2. And the radius goes up, and it increases by x squared. It increases by these distances here. So it's 2 plus the x squared for the entire radius. And then the h, again, is infinitely small for each of these, so that's the dx portion. And that's going to be the area of the blue region that I shaded. We want to subtract from that, and this part doesn't involve calculus. We want to subtract pi r squared, so pi times 2 squared, and then the height is 4. And then, again, this is for the orange region that we were talking about. The orange region gets revolved around the line y equals 2. So the orange region comes down here. That's a perfect right cylinder where the radius is 2. From here to here, it's 2. And the height is 4. Okay, so that calculation, once you expand this and then you integrate, find the antiderivative, should get the right answer there. And then the line x equals 6. Now this is changing how we're integrating, because x equals 6 is out here. Now we're not integrating with respect to x. Now it's going to be easiest to integrate with respect to y, because we're revolving around this way. Let's see. Yeah, because it's getting revolved over here. So it's the same approach as what we had last time, except now we need to put things in terms of y. So this is x is the square root of y. Oops, I can't undo right now. I don't know why. Adobe won't let me do it. Same expression. This is only dealing with the positive side, which is what we want, right? We only want positive values for x. So this equation will tell us the x distance it is given a y value. And we want to do that because now we're rotating around, rotating from a different perspective. Instead of top to bottom, we're rotating from left to right around the line y equals x equals 6. So we want everything in terms of y now. So the lowest y value we have for this integral, actually, this is from here. I got to redraw it. I'm getting confused from the last problem. Here's the x squared graph. Then we had x equals 4. So there's our region. And then we're rotating it around x equals 6. So this equation is y equals x squared. Or if you want to only look at the right side and forget about the left side, this is the square root of y equals x. Okay, so if x equals 1, y equals 1. If x equals 4, then y equals 2. Okay, I said that wrong. If x equals 2, then y equals 4. If x equals 3, then y equals 9. So this is modeling the same relationship just on the right side of this parabola. And we need that because now we're revolving around a vertical axis of revolution, this line right here. So we can use that same approach. You've got a right cylinder. When you make this revolution, it goes from here to here. You've got a right cylinder that you're revolving around. We just want to subtract that right cylinder out of this entire area. We'll find this volume that goes all the way across. And then we'll subtract out the right cylinder that has, let's see, this is x equals 6. So the right cylinder we're taking out has a radius of 2. So pi 2 squared. Because this is x equals 4. So the x equals 4 to x equals 6, that's a radius of 2. And the height, actually we need to know the height. How high does this go up? It's pretty quick actually, because if you're plugging in x equals 4, then y is going to be 16. So this point up here is 16. So the height of that right cylinder we're going to be taking out is 16. Okay, but now we need the calculus part. We need to define the volume of an infinitely small right cylinder, like where the line is that I just drew. So the radius of this cylinder, so the radius of the right cylinder goes all the way across. Right, so the radius it's 4 plus 6, 6 minus 4, so that's a distance of 2 here, plus whatever this x distance is here. And so in terms of y, so I actually had to stop the video. I made a mistake. I Everything's set up correctly up to this point in the video. But the mistake I made was I was saying that this is defined by the square root of y. But this distance, x equals square root of y, is actually from here to here. Right? It's this distance here. And we want, let me see if I can change colors. We don't want that red distance for our formula for volume. It won't let me do it. We want this distance right from here to here. So to do that, you want, for the radius, it's a radius of 2 plus, and then this is going to be 4 minus the square root of y. Okay, and the reason is because when x equals 4, then y equals 16. Square root of 16 is 4. 4 minus 4 makes 0, right? This distance is supposed to be 0 once we get to the top. And then the distance we want here is whatever this blue distance is subtracted from 4. Because the entire distance all the way across is 4. So this has to be our radius. So to do that, to finish the volume calculation for this entire region here, revolved around x equals 6. We start from 0 on the y-axis to 16 on the y-axis, and then it's pi r, which is actually, you could just say 6 subtracted by y, the square root of y. That's our r squared, and dy we will say, because our height is infinitely small for each of those. So it's poorly written, but I can't undo like I usually do in these videos right now. But this is for the volume of the entire thing, and then we got to subtract out that central part that we talked about earlier in the video. So this calculation should get you the right answer.